Yes, good morning and all. So, food paper title is IoT based healthcare a survey. So, my session ID is A1680. Okay. So, I'm now presenting the slides of my conference. Okay. So, authors for my paper IoT based healthcare survey are myself, Muhammad Imran, and Andullah Bharat. Okay. Now, I'll be starting the paper. So, here you can see. Title is IoT based healthcare, Internet of Things, how based healthcare. So how this healthcare technology is helping the people, and how the IoT is helping in terms of healthcare. Okay, so we'll be seeing this slides, healthcare and IoT introduction slide, and applications of IoT, sensors and wearables. What are the different devices? Okay, then infrastructure of IoT, handheld devices and wearables. Okay, how it monitors energies and some challenges and some directions. Okay, and this is server paper. Okay, so coming to first slide, there is healthcare. Okay, healthcare and IoT. So healthcare landscape is growing. Normally these are the problems in that: obesity, poor diet, and population is aging. Number of people older than 65 in the US is 70 million. uh, it's still growing, and 70 to 80% of healthcare are spending in is on chronic disease management, and huge market for new systems which improve the productivity, cost, cut the cost, and support the shift of healthcare from hospital to home. Okay, next one are different applications of IoT, Internet of Things. So it helps in monitoring the analyze and then monitoring the patient's behavior. Okay, how the patient is behaving in that situation. Then stress monitoring levels. Okay, what are the different stress, like based on the emotions, IoT sensors will be capturing the emotions of the patient. Then monitoring the social activities. Okay, next preventive healthcare and continuous multi-parameter. Next one, monitoring the situation of the patient. Next, using IoT to monitor different therapies. Okay, using healthcare monitoring to improve the drug discovery and development. Okay, so again, we have improving process. So finding the people and equipment by tracking the location. Okay, first setting the particular device to some location based upon the sensing. Okay, sensors. Next, tracking the hospital equipment. Like administrator will be having these controls. Next, patient ID and tracking. Some device will be there which they'll be attaching to the hand. Okay, or some leg like that, and they'll be tracking the patient details. Okay, next one, preventing medication errors. Even we can track the blood samples. Okay, or tracking samples. Next, product recalls. Okay, so recall is a thing where you can recall, means if it's saving the memory, then from there we can recall it. Okay, next one, tagging implants and removing the charging of batteries. Okay, next, sensors and variables. So how the sensors and variables is performing now, and what it can be the future. Okay, so monitor sensors and variables monitor the vital signs, falls and wandering, and it assists the alarm, notification and graph. Okay, so by this way you can see heart rate monitor, pulse oximeter. Through sensors they will be measuring all this. So some points are set. Okay, like hand. Okay, heart, and some positions are set. Okay, next, future how it will be. So monitor more, some new features will be there, like context aware management, daily activities and social interactions. Okay, based upon that, they'll be monitoring the behavior of patient, assist more, so accurate, stimulate, transfer medication as needed. Next, infrastructure sensors. So these are some kind of remote, combined wearable and remote. Okay, and close proximity detection or measurement. So remote like radars and cameras, CCTV cameras. Next, you can have property exit sensor or bed occupancy sensor and pressure mat. So based upon this also we can monitor the situation of the patient. Next, combined wearable remote, it is real-time locations based upon the GPS. Okay, and close proximity detection or measurement, pressure mats or bed occupancy sensor. Next, applications of infrastructure sensors. So monitoring of health signs, human environment interactions, monitoring falls, human physical activity. The next one, sensing and form factor. We can maintain this through a smartphone. Okay, or headphones. You can wear the headphones and listen it. Okay, shirts, hearing aids, smart watches, shoes, so smart jewelry, okay, dental appliances, like armband, some band wearable at the hand, and eyeglasses. Okay, so these you can see how it looks. Okay, next one, activities and interactions like RFIDs. Because these are based upon the radio frequency thing. Okay, next, you have a near field communication. Even this one is new technology. Far field RFID. So it has some ranges. Okay, 10 meter. Again, current applications are detecting presence and wandering and retirement homes. Okay, and future sensing applications like detecting interactions and activities and localize the people. So we have some kind of tags, RFID tags. Okay, and in turn it will be connected to the RFID reader through that through antenna. So we can connect to the laptop and we can monitor it. Okay, and it will be sending signals based upon the electromagnetic waves. Okay, and so again we have this RFID sample tags and readers. So sample tags is looking like this: UFT matrix, plastic crate tag, UFC rucksack, and here sample readers like antennas. So the antennas, it will be connecting the data. Okay, so like stationary reader antenna, sync post activator, handheld reader. Okay, all these are some kind of devices. Okay, so stationary readers are typically deployed at warehouse portals or loading docks or a central level on conveyor belts or forklift arms on store. Okay. So next one, basic types of tags. We have three different types: active, passive, and semi-passive. So these active tags transmit radio signal, battery, and it is battery powered memory, radio, and circuitry. So is dependent on the battery. Okay, and the range. Okay, high range range, that is 100 meters. So in active you can perform the reading from till 100 meters. Next one, passive tag reflects radio signal from radar, and it's radar powered, and it's short range up to from 1 centimeter to centimeters. Okay, next one is semi-passive. So it communicates with the reader in the same way as passive, and it has batteries from the electronics. And for semi-passive, the range is up to 30 meters. Again, we have this power consumptions. Okay, so batteryless sensors are also coming nowadays. So temperature sensing patch will be there, knitting the antenna into a sweater. That is also possible. Okay, and recharge the batteries based upon radio frequencies, temperature, and movement. And again, we have low power design like communication processing, and flexible battery is also there in this. So this is some kind of magic strap RFID chip. Okay, so this is how it looks, and this is some kind of sensor. Okay, sensor, or you can say the temperature sensing patch. It is knitted into antenna, knitting the antenna into a sweater. Okay, so next one is data quality and content. So here it's, as you know, it's a unsupervised data collection method, automatically or by the patient manually. Okay, so quality, how do we know the data is accurate or correct? So quality of raw data, data aggregation, and data, and it is learning algorithms by through making the devices learn the algorithms. Then identify and quantify the noises, artifacts, and activities, and also by automatic signal quality analysis and mitigation. So we can know that the data is correct or accurate or not. Okay. Then content, what data implies emergency. So because of no false alarms will be there. So this is our presentation. Thank you, Anand. Thank you. Thank you, Anand.